Okay, last question. I've got identical lamps and we can see that they're connected in series. It tells us we're going to put 12 volts in. And we know that that 12 volts, assuming they all have, and that's why it's got the word identical lamps, which means that they have identical resistance. That's why they've had to put that into the question. It says, what's going to happen? Well, we know that 12 volts is going to be shared with all those things. So you just count all of those things. So 12 divided by 8 beautiful things equals 1.5 volts. Easy, done. So the next part is the power output of each. So I've got power, P, is that calculate the resistance. So this is a tricky question because we can see we know certain things. We know the voltage. We are given the power, and it says calculate the resistance. So there's lots of different ways of doing this because these equations are all interconnected. But the basic idea is I'm going to use my IP violently and shove it into Ohm's law, or IC pink rabbits. So there's the basics. Because I've got a voltage and a power, enables me to work out the current. Now that I know that and that, I can work out the resistance. And you can see now that I know that and that, I can work out the resistance. So give me the same answer. So to just rub it up all of that and tidy this up. Tough question this, multi-step. So basic idea is we're going to need the IP violently, and then I can go one of two ways. I can put it into Ohm's law, or I can put it into IC pink rabbits, and you'll see that model now. So first part, we know it, but I need to go and find the current. So P equals I times V. I want to find out the current. I equals P divided by V. The power is 0.75 divided by the potential difference up there, and we can see what's high here as well. I've got to use an answer that I worked out. I now know 0.5 amps is flowing through those. And then it's pick which one of these, all right, because either one has R in it, so I can use it. And you'll see it gives the same answer anyway. So R equals P over I squared, perfect, 3. R equals V over R, Ohm's law, 3. Does not matter which of those I pick. Answer 3. Go on to the next one. Explain with the aid of a circuit diagram. I've said to you multiple times, it's one of the most important questions you need to learn. So it's how do we measure resistance and stuff? And you did it practically with lamps and diodes and fried all my diodes so that they never worked again. But you did this practically and you did it well. And hopefully you remember dancing those beautiful voltage current graphs where I had to use every ounce of persuasion just to get you to dance. Here we go then. First thing, I need that blinking diagram. So it's some cells or a power supply unit, a variable resistor, because I need some way of altering the voltage. And then I'm going to measure the current. So you can now see I've got a single lamp. There's my bulb, my lamp. You could even use the ohm sign in there. It doesn't really matter. But I've got a power supply connected in series, but with my voltmeter connected in parallel around the bulb. It's got to measure the electrical energy in and out of this bulb. All right. And then we're away. So once we've got that diagram, use the variable resistor, use U, to set this to 0, 1, 2, 3, 4, 5 volts. Perfect. Measure the current using the ammeter. Perfect. Then use Ohm's law, R equals V over I, to calculate the resistance mark. Repeat at least 3 times for each potential difference. So I did get you to learn that really well, but it's been a while since you've done it actually, so I'll put it into retrieval practice if this is done badly. But there's the basics. So if I quickly just come back out of here, explain with the aid of a circuit diagram, I'll draw it slightly differently. Get a power pack, get my bulb. I would lose a mark for these gaps, by the way. Get an ammeter in the circuit. Lost a mark, there's no variable resistor, put that in. Next part, lost a mark, I need a voltmeter around the bulb. And there's the basics. And the next part is, in terms of me going through, use this to set this, measure this. Ohm's law, I'm very rich, R equals V over I. And of course, you've got that beautifully with that. And I think that's me done. Perfect.